In this tutorial, we are going to talk about Java Collections Framework, which is a very good framework and a very useful framework. And in this framework, this collections framework, Java provides some of the implementation of the data structures, for example, linked list, stacks, queues, maps, hash sets, hash tables, tree sets, etc. So in this tutorial we are going to focus on linked list and stacks only, and in the further coming parts we will discuss about some more of them. So in Java Collections Framework, basically if you don't know about what exactly data structure is, so let me just tell you what data structure exactly is. So let's suppose you have some data, let's suppose you have some integers. So let me take some random integers like 4, 5, 10, 13, 11. So you have these integers, and these are basically data. So if you want to store this data, you might need to perform some actions on that data, right? So you might need to uh, get some values from this data structure. So a data structure basically holds data in a specific particular pattern or a manner. So we're going to talk about two data structures in this tutorial, which is linked list and stacks. So basically we are going to use the Java Collections framework to implement linked list and stacks. You can also implement these two data structures using just memory references, but since that is a complex task and we have already done that using C++, so now we are going to see and explore how you can very easily create and perform some operations in these two data structures. So let me first define the first one, which is linked list. So basically linked list is a collection of data, or the data is known as nodes. So let's suppose you have these integers. So now you want to represent it in a form of a linked list. So as the name suggests, it is a list of the data linked together. So we are going to link these nodes using memory references. In C++, we create pointers, which is the next pointer, and it points to the next node like this. So basically in any other if you're not using the collections framework, you will have to create memory references, and you will have to work around a lot of stuff. Like if you want to add some value to this node, you will have to find the accurate position for it, where you want to add it, and you will have to manage a lot of stuff. But if you use the collections framework, and we are going to use the java.util dot asterisk, so we are going to import this util package, which basically provides which has already implemented these data structures. And what we are just going to do is we are just going to make some calls, some function calls, and the work will be done. So let's move on to the Eclipse IDE and implement our first data structure using the collections framework, which is linked list. So here we are going to demonstrate linked list stacks using collection framework. So first thing first, import java.util asterisk class. So we are going to import this whole you can say this package. So now what we are going to do is if you want to create a linked list, you will since we have imported this util package, now you can easily create a linked list class like this. So let's name it as LL using new operator, linked list, integer. So you can see that this is this linked list is basically a class, and you can see that the difference here is you might notice that we have written this extra thing integer in these two arrows. So basically this is a generic class, and generic class is basically a class which which you can use to implement data structures which have different data types. So let's suppose you want to create a linked list of integers. You can actually specify that this linked list can only add integer nodes in the linked list. So this is basically a generic class, so you will have to specify in these two symbols. So very simple. So now when you write this line, it will create an empty linked list. So what now I'm going to do is I will add some nodes in our linked list LL. So in order to add the linked list, you do not need to create any memory references, or you do not need to do any stuff because it has already been done by the Java programmers, and now we are just importing those packages, those classes, and now we're just going to make some function calls to add some values to these uh, linked list or stacks, to these data structures. So first we are going to use the dot operator, and you can see that when you will write dot after that, you will see there are a lot of recommendation here, like get or add, and there are a lot of recommendation that it is showing us, remove. So basically this linked list generic class provides a lot of inbuilt functions which have been already defined, and what you are going to do is you're just going to call that function, and you will have to provide it with suitable parameters, and it just works like magic. Your linked list will be created without even managing anything. So let me add some integers using this add function. So you can see here that I have inserted 4 in our linked list using the add function, which is a predefined function. So I'm going to write here adding elements in our linked list, right? So now we have added 4 in our linked list, and you can see here that I have not implemented this add function anywhere. I have not implemented the memory references. I have not done any complex tasks because that has been already done in this linked list class, which is placed in this java.util package. So I'm just going to call this add function to add some more elements inside this inside our data structure, which is linked list. So let me add some values. Right, so I've inserted 5 values to this linked list, and when you will add these elements in the linked list, then they are added in the form of linked list. That means that if you are on 4 node, or you are on a node which is having the value 4, so the next pointer will be pointing to the next node, which is 5. So they are in order, right? So 4 isn't inserted first, then 5, then 10, then 11, and then 13. So if you want to display this linked list, or if you want to display contents, or I should say nodes of linked list, then it is very simple. You do not need to create any function or anything. you will just have to write system.out.println, and inside you will just have to pass the linked list, which is ll in our case. So you can see here I have created a linked list, I've added some values to it, and now I'm printing it. So let's see, let's run this program and see the output. So you can see here that it has created a linked list which has values 4, 5, 10, 11 and 13. So we have actually implemented a data structure linked list without even writing any functions, or without even doing any uh, implementation of these functions or doing any complex tasks. So collections framework is basically a very intuitive framework which helps programmers save a lot of time. So the programmer will not be not doing the most of the time, they will not have to implement these functions. They have already been implemented, and since these are the most basic data structures, so that's why they have been added in the collections framework. So let me show you some more functions that you can implement. So let's implement this add first function here. So this add first function, as the name suggests, it will add the node at the first position. So let's say I want to add 12 at the first position. So I'm going to write it like this. And let's implement one more function, which is add last function. And let's add 87 at the end of our linked list. So let's run the program and see the output. So you can see here that 12 has been added to the as the first node of our linked list, then 4, 5, 10, 11, 13, and 87 is added on the last node. So you can use a lot of functions to uh, and you don't need to implement these functions. You can see here I have not implemented the add first and add last function. They are already present there, so you can use them. So let's suppose I want to get the value of a specific node. So let me create a variable a, and let's suppose I want to get the value of the third node, right? So I'm going you can use the dot get function to get the value at the third node. uh, Remember to write the ll, which is our object or our instance, to the linked list generic class. So now we will just display the value of a. So let's run the program and see. So you can see here at the third position the value of the node is 10, which is 0, 1, 2 and 3. So in this manner you can get a particular node. You can even remove a particular node from the linked list using the remove function, and there are similarly more functions that you can implement. So this is basically our example of linked list data structure. Now we are going to move on to our next data structure, which is stacks, right? So let me first give you an overview of what exactly a stack is. So now we're going to discuss about stacks. So let me give you a real life example of how the stack data structure looks like. So let's suppose you have a tube or a container like this, which is open from one side and it is closed from the other side. And I will give you some balls which have numbers on it. Let's suppose the balls are 4, 5, 10, then 13 and 11. So now what I'm just going to do is I'm going to give you a task of putting uh, or to insert these balls inside this tube. So let's say that this is a stack. So what you are now going to do is you're going to first insert 4, then you are going to insert 5. Similarly, you will insert 10, then 11, and then 13. Right, so one by one you are inserting into this stack. Insertion in a stack is known as push. So there is a push function which you will have to implement, but since we are using the collections framework, we do not need to implement this push function. We are just going to make a call to the stack generic class function push, and then it will automatically push the value given inside this function push, and it will insert it into the stack. So let's suppose I say now I give you a task of removing this fifth ball, right? So I am saying that you will have to remove this ball which has number 5 on it. So you know that if you want, you will have to remove this ball, and you will first have to remove the balls 13, 11 and 10. So then only you can remove this fifth ball. So this removal or deletion from a stack is known as a pop, and we are going to call the pop function in our collections framework to just remove a particular data or a particular node from our stack. So you can see that pop function pops out or removes the element which is at the last position of our stack, which is, you can see here in this case, 13. So if I will just call the pop function, it will remove 13. Then it will then the elements remaining in the stack will be 4, 5, 10 and 11. Again, if you will call the pop function, it will pop out 11, and this goes on and on. So a stack is basically a data structure which follows this rule, which says first in, last out. Right, so the element that you have inserted first is going to become the last element to come out of the stack. So if you have inserted 4 first, it is going to become the last element to come out of the stack. Right, so what we are going to do is we are going to use the collections framework, and we will add these data or these nodes in the stack, and then we will call the push function and pop function, and we will see how this actually works in the Eclipse IDE. Okay, so in order to create a stack data structure, it's very easy. Just create a stack generic class. So let's now provide it with some other data type that this stack data structure can hold. So I've written string here. So stack, let's say stck equals new stack. Being a generic class, I will write here string. So now you can see I've created a stack generic class. So I'm going to write here that it is a generic class. So it provides a general mechanism or a template so that the particular data structure can be implemented using this data type, right? So let's add some value in this stack. So in order to add, if you want to add some elements into the stack, you will have to remember one thing, which is if you want to insert something into the stack, you will have to use the push function. There is no add function. We are going to use push function, which pushes an item into the stack. So let's say we are going to insert hello as the first string item. So let's push some more items into our stack. Hello world. So I've just inserted these, I've just pushed these two strings in the stack. So if you want to print out the contents of the, it's very simple. You will just have to write this thing, system.out.println. So I'm going to write here display contents of the stack, right? So and here we are adding elements, so I'm going to write here pushing elements into the stack. So now let's run this program and see the output of this program. So you can see here it has created a stack with values hello and world. So this is how a push function works. Push function is basically the insert or the add function, and you can see here even in this data structure I have not implemented the push function because the collections framework which exists in this util java.util package has been already implemented. So you can see how much compact our program becomes and how much easier it becomes for any programmer to implement data structures without worrying or implementing these insert functions or push function or pop function. So let's create the pop function. Let's call the pop function and see what will be the output. So when you will call the pop function, it will have to pop out an element from the stack inserted in the last. So now the result should be hello inside the stack. So let's see the output. So you can see here that now it is saying just hello because we have called the pop function. So if your stack is empty and then you try to call the pop function, it is just going to it will display a null pointer exception. So you can handle that exception here. So in this tutorial we have covered the java.util.collections framework, and we have covered linked list and stacks. In the next tutorial we are going to cover queues, hash maps, hash sets, tree sets, and some more basic some more keywords like iterators and split iterators. So thanks for watching.